Okay, so thanks for inviting me here today. So I'm going to talk about a range of projects that we've been working on, mostly funded by the MRC, to look at ways to better stratify medicines in the autoimmune disease area. And we're using TranSmart widely for these projects. I'm actually going to talk a bit about TranSmart, but not a huge amount, so I think you've probably heard a lot of this before, but I just want to say that TranSmart is underpinning everything that we're doing in these projects. So the challenge that we're trying to address here is to find ways to better treat immune mediated inflammatory diseases. So that's quite a mouthful, so I'm going to call it IMIDs from now on. So these are chronic diseases with prominent inflammation that are caused by a failure of tolerance in the immune system or a failure of regulation of the immune system. And they include things like RA, psoriasis, lupus, inflammatory bowel disease, and so on. They affect about 2 to 5% of the population, and the incidence of IMIDs is increasing. So they're thought to be caused by response to self-antigens, autoimmunity, and also potentially by microbial antigens. And there's a lot of work going on around the role of microbiome in these diseases as well. And they can be systemic, like in something like lupus, or they can be organ-specific in psoriasis, skin, but also usually that has a systemic effect. And the pathology is highly overlapping. And if you want to see how overlapping pathology is, you just look at joints and look at the hand, for example. Now this is actually one of my favourite slides to describe the overlapping pathology of IMIDs. So if you look at the hand, according to where the joints are affected, you can see that a whole range. If you have a swollen joints of your hand, you can kind of look at which joint is affected, and then there's a whole range of different diseases, some of which aren't even IMIDs, some things like hemochromatosis and gout. But these are all highly overlapping, and you can see RA has joint swelling, lupus has joint swelling and skin inflammation, and psoriasis, of course, has skin inflammation and joint swelling. So there's a lot of shared pathology, for sure. And this is reflected in the drugs. So IMID treatment has been revolutionised by biologics. So one of the first wave of biologics were the anti-TNFs, and these have been approved for at least 6 IMID indications. Psoriasis in skin, joint with RA, and psoriatic arthritis in the gut. What's notable is that it doesn't work in everything. For example, anti-TNF is not effective in lupus, so wonder why is that? And so the problem with anti-TNFs, although they are effective, they have 60 to 70% efficacy, which is much better than small molecules, things like methotrexate, but they're very, very costly. They cost about £20,000 a year, or €20,000 a year. And there's a next generation of biologics coming into the clinic, and these are much more pathway focused, looking at things like interleukins. They tend to be more effective, so they've got increased efficacy, but they're increasingly niche, and they're being used for specific diseases. So we have 4 projects that you saw these on Jay's slides earlier that we're working on to understand the role of biologics and to stratify biologics. And these are highly overlapping. They're all using TranSmart. So we've got RAMAP that's looking at RA disease biology, Mature is looking at RA biologic response, SORT is looking at psoriasis biologic response, and Masterplans is looking at lupus biologic response. So we want to understand and stratify biologics by endotype, so by the different forms of these diseases. It's a substantial MRC investment. It's a total of 20 million across these projects. and we are leading, within my team, we're leading informatics for these projects in partnership with eTrix. eTrix really took a big role in RAMAP and has been instrumental in making RAMAP a success. And then we've kind of taken that on and translated what was created for RAMAP into these other projects. So what is an endotype? We had someone talking about endotypes yesterday, but I think this is how I'd like to describe it to you. So if you consider, say, in something like RA, there are actually three known. If you look at the histopathology of an RA joint biopsy, you see three different types of RA. Although the patients all look the same in the clinic, there are actually three underlying molecular mechanisms that have been described in RA so far. So if you take these three mechanisms and you give them a drug that is focused on one mechanism, say rituximab, which hits CD20 of B cells, only one endotype of RA has B cells. So if you, let's say it's this endotype, so if you give a B cell targeting drug to a mixed population of RA without regard to endotype, you're going to see partial response because these endotypes don't respond. But if you select your clinical trial or your patient population with regard to endotype, then you're going to see a much higher response rate. So that's the principle of why we need endotype data. And in regarding hunting endotypes, so RA were probably more advanced than some of the other IMiDs. We're really studying these IMiDs from the ground up, so we're doing lots of multi-omics, genetic studies, epigenetics, omics, transcriptomics, protein, and looking at things like drug response and connectivity map, and across a range of tissues, and also using flow cytometry. And then first off, we're trying to identify disease endotypes, so this is basically what molecular changes are caused by the disease, based on a change of omic perturbations. And then we look at the drug endotype, so this is what the drug does to the body, so what gene expression and other omic changes occur when you treat with the drug. And then the idea is that if you overlay the two, you can then pick out biomarker panels that will classify endotypes. So when we're generating this data, there's a lot of omic data being generated in a very complex manner across lots of different panels, across many patients with a lot of clinical data. If you try to bring all that together and integrate just in one disease, let alone across diseases, which is our ultimate aim, you really need standards. And we had the analogy yesterday of data being like oil. Well, I'd like to sort of say actually that data is more like it's a commodity. And the way that commodities are moved around the world now is in these containers. You see them in ports everywhere around the world, but whatever port you go to in the world, it will have this configuration of container. And that has made the movement of commodity around the world very efficient. And I'd like to just sort of have a think about what it was like before we had these containerized data warehouses. Before that, we had misshapen boxes of all shapes and sizes, and like five guys have to pull out two crates rather than a crane just chuntering through a whole warehouse. And I think this is what we need to get away from with the way that we deal with data, and I think we're still doing this a lot, and we need to go more to standards. And I am preaching to the Vatican here. So the reason for doing this is to get all the data in one place, to preserve the rich metadata and the clinical phenotype that we're measuring with extreme care in these studies, and more of that later. We can decouple the identified data, which is really important to allow us to do research. We can curate and integrate the data. We can overlay advanced analytics that can work across standardized data. And also, a really important thing about TranSmart is it allows us to manage access fairly and securely so that the data is available to the whole consortium and not just kind of piecemeal. But the whole concept of open data is something we're trying to move towards, but open data is not enough, and I think this is actually a really huge issue. This has already been raised several times in this meeting. We really need to make sure that our data is reproducible. And I think the debate yesterday about open data is, in a way, I'm kind of past that, because we kind of, everybody agrees that we should have open data. What I'm more worried about now is reproducible data, and I'll give you an example of that. So we clearly need standards. We've talked a lot about standards. We have seen this talk earlier. Now, if we apply standards to the way that we generate data, you could get really excited about a database like the NCBI GeoOmnibus, and we're all curating this data and putting data as TranSmart, and we've done this across the units. We've tried to get all of the good transcriptomic studies from Geo. And if you look at these kind of figures, you can get really, really excited. There's, it's a goldmine here. But before we get too excited, if you actually start to drill down to these, and I'm sure you've all experienced this, you look at a study, and so here we've got a study of 25 psoriasis patients that were given a biologic drug. There's lesional skin samples and non-lesional skin samples. Expression profiling by array. This is a great study that we'd really like to mine. But then, when you look at what data there is in there, we've got this time point, whether it's lesional or non-lesional. We've got the dose of the drug, and that's it. And we've got patient ID, but that's not very informative. We don't have gender, we don't have ethnicity, we don't have disease severity, PASI scores, we don't have response, nothing else. So the first thing you do is you contact the data owner. This is also a familiar conversation. So I contacted the owner, said, we'd like to meta-analyse your data. Could you provide and share the clinical data? And I got a response pretty quickly, actually, and in good faith. But the response here is maybe it's typical. So, dear Mike, I no longer work for Amgen. Amgen no longer has the rights to share any of this data because they've sold it to someone else. I believe Amgen provided the data to the CRO, but and the trail goes cold. So in effect, that data is now is well, it's not useless. It's hard to use and far from ideal. So you probably all heard about Miami. I think the real issue here is that Miami exists, and we all agree it's a good idea. But how many of you review articles and you might see that somebody's put something in Geo, but do you actually check? And I think one of the issues here is that we really need we can say, well, this must be changed, we must have open data, it should be enforced by the databases, it should be enforced by the journals, but actually I think it's you guys in the room that are reviewing papers, you're the ones that need to make sure that the full clinical phenotype is in the database. For whatever reason it's not there, it might be that it's genuinely overlooked, or it's maybe that it's been held back for some reason or other, but that is what we really need to do. We really need to, as reviewers, I think we're the most powerful force to actually get clear, complete open data. So going on to infrastructure, TranSmart is the tool that we're using to capture all our data, and it's working really well for us. I don't really need to tell you what TranSmart is, you know what it is, but it's working out to be a translational platform that's improving all the time and becoming more and more functional. We've seen the advances of the platform. We're also using I2B2, and for us, the only current limitation of TranSmart is the inability to capture event-based data. So if you want to capture an electronic health record, that's difficult. It has to have fixed time points at the moment. As I2B2 and TranSmart come together, I guess this slide will change, and we'll probably end up using one system. But at the moment that we're using both, and they interact quite well in an ecosystem. And so for our stratified medicine projects, we've got this kind of totally interchangeable slide that whenever I talk about a different project, I just I move one of these boxes from here into here, and you've got a description of the infrastructure. We basically clone the infrastructure across all 4 of these projects. And you're familiar with the process. You get clinical data, the omic data, literature reference data, standardized, loaded to the database. It's there for analytics. It's there for staging of data and sharing of data in the consortia. Just to give you an example of how we're using TranSmart, RAMAP is our most sort of advanced project, and the analysis team in RAMAP have done some really nice work with clinical data, identifying response trajectories using latent class mix models. Now that data classifies patients, so patients fall into 3 different response groups, and you can load that into TranSmart, so you know which response group your patient's in, whether they're a good responder, a poor or a moderate responder. So you can then use that to run queries. So here's an example of a query. This is the RAMAP data tree, where you have really rich data about blood counts, disease activity scores, all of the bloods that you do in RA across every 3 months for 18 months. And this is for 270 patients. And so you can run a query like this one. So you can say, if I take the good and the poor responder trajectories from the latent class, then how do the platelet counts differ? So you can see there's quite a clear difference here between platelet counts and quite a significant difference. So it really does allow you to do some quite nice exploratory data analysis. And then, of course, open data sharing. We're generating data. This is a whole other talk to talk about the actual data that we're generating, the hypotheses that we're forming. And I'm not going to talk about any of this, but there's a lot of data coming out of these projects, and the manuscripts are starting to go into the journals, and hopefully I'll have more to talk about another time. But we get into really nice data where we've got rich, highly organised data, and so we can do things like module analysis. This is show spell module analysis, and we can look at different classifiers using random forests. We can generate heat maps. We can classify disease subtypes and trajectories. So when it comes to actually sharing this data, we will certainly do everything we can to kind of practice what we preach, and we'll be depositing the data in Geo and in the EPI databases. I also think that we need to find a way to share VM images and the actual data that goes into the VMs, because that's a lot richer. I'm not entirely sure that we could represent all that data that we have in TranSmart in Geo, so it has to go somewhere else. And so I think detailed TranSmart images or load files really need to be captured, and I think that's an important thing to discuss. We're also, I think a really important point is to share the analysis code that you use to analyse data. So we're using GitHub to capture our analysis code as much as possible, and we're trying to make sure that we publish the analysis code that we use with the paper. So the data is available and the code is available, so it's completely reproducible. It should be reproducible. And to give you an example, here's a GitHub. Now this is still private, but when the publication goes out, we'll make this particular repository public. where we've got the analysis code for some of the sort analysis, and we've got markdown documents that really step through all of the steps in the analysis. So giving you commands, giving you expression, EDA, and so this really allows you to reproduce data. So ultimately, this, we hope, will give not just open data, but reproducible data. And so just a bit about where we're actually hosting all this and storing and how we're enabling the heavy lifting with the compute and the analysis. So we're using the MRC eMedLab cloud computing cluster. And this is a £9 million hardware investment by the MRC to 7 partners. So it's led by UCL and the CRIC. But there's other parts, Sanger, King's, Far Institutes, EBI, and Queen Mary. And so eMedLab is a hub for collaborative analysis. We're using it for all kinds of analyses, genomic data, imaging, electronic health records. It's got 6,000 cores, 5.5 petabytes of storage and fast connects. And of course, it's an open stack infrastructure, so we're using it to host VMs and different VM infrastructures for analysis. And so within eMedLab, we've now got 6 projects that are using TranSmart. So there's the 4 that I've spoken about already, but there's also a juvenile arthritis project called CHART that's starting to use TranSmart, and Target, which is working on giant cell arthritis. So we've got great synergy here. So we've got 4 inflammatory arthritis projects, 5 projects focused on biologic therapy, and all of them working on inflammatory disease, and a common infrastructure across all those projects. So it's working well and synergizing. There I'd just like to go to acknowledgements. So it's really a team effort. I think the biggest acknowledgement probably has to be to the eTrix team, not just because I'm at the meeting, but they've really helped us get off the ground with the infrastructure, and particularly in our area, Francisco and Denny at this meeting, at Janssen working with Anthony Rowe. They've been a huge help. They've done all the data curation and the database builds and TranSmart builds for our eMap. And then in StratMed, there's the leaders of the various projects and my own team. Thank you.
Thank you very much. And I think we might be 60 projects now that target and chart.
Hi, Mike. Just related to your statement for the sharing of data in the form of TranSmart VM. In Elixir Luxembourg, we do provide such support. And also in eTrix, we are building the catalog, which try to expose the metadata that have people to fund your data set.
That's good to know. So you're offering to long-term archive data sets. Okay. It's probably a good idea to have something in 2 places just in case. You know, England sinks or something like that. You never know these days.
And Mike, just out of curiosity, you mentioned that for some projects you use I2B to TranSmart in tandem on the same data. I'm assuming even on the same database. I don't know many examples where it's done in a few places. So what would you say are the use cases that you can do an I2B to only versus ones in TranSmart only? And does that change with Z3.1 would be my next?
I hope it does. It's running the 2 of them in tandem is twice the work. The use case specifically is for SORT, which is the psoriasis project. And there we've got a biologic registry that's got ongoing accrual of electronic health record data for about 13,000 patients. And that, because it's EHR, event-based data, you can only represent that I2B to. And then we're using that to link, based on patient ID, to TranSmart to the omics. But it is only a patient ID link, and that's all. So they're not really tightly integrated.
So, if I may, what you're saying is that you need I2B2 interface to ask questions like, how many patients do we have with event X in time, and then event I, which is later or earlier, so temporal relationship varies.
Cohort discovery, yeah.
Okay, yeah, that should be possible now in Safety Online and TranSmart directly.
Well,
so that'd be great to test.
Yeah, it will, yeah.